Hello students, today we are going to discuss research and documentation. In that, we will be discussing sampling. Sampling. Sampling is the process of selecting units, example, people or organizations, from a population of interest so that by studying the sample, the results are generalized for the population from which they were chosen. The purpose of sampling is to reduce the cost and or the amount of the work that it would take to survey the entire target population. A survey that measures the entire target population is called census. Sampling methods can be classified into two categories. Probability sampling. Sample that has a known probability of being selected is called a probability sampling. Non-probability sampling. Sample does not have known probability of being selected, as in convenience or voluntary response surveys. Probability sampling. A probability sample is a sample in which every unit in the population has a chance greater than 0 of being selected in the sample, and this probability can be accurately determined. The combination of these traits make it possible to produce unbiased estimates of population totals by weighting sampled units according to their probability of selection. Example, we want to estimate the total income of adults living in a street. We visit each household in that street, identify all adults living there and randomly select one adult from each household. For example, we can allocate each person a random number generated from a uniform distribution between 0 and 1 and select the person with the highest number in each household. We then interview the selected person and find their income. These are the methods of probability sampling: simple random sampling, stratified sampling, systematic sampling, cluster sampling and multi-stage sampling. Simple random sampling. A. Simple random point sampling. In this, a grid is drawn over a map of the study area. Random number tables are used to obtain coordinated grid references for the points. Sampling takes place as feasibly close to these points as possible. B. Simple random line sampling. In this, pairs of coordinates or grid references are obtained using random number tables and marked on a map of the study area. These are joined to form lines to be sampled. C. Simple random area sampling. In this, random number tables generate coordinates or grid references which are used to mark the bottom left, southwest corner of quadrats or grid squares to be sampled. Advantages and disadvantages of random sampling. Advantages: can be used with large sample populations, avoids bias. Disadvantages: can lead to poor representation of the overall parent population or area if large areas are not hit by the random numbers generated. This is made worse if the study area is very large. There may be practical constraints in terms of time available and access to certain parts of the study area. Stratified sampling. This method is used when the parent population or sampling frame is made up of subsets of known size. These subsets make up different proportions of the total, and therefore sampling should be stratified to ensure that results are proportional and representative of the whole. A. Stratified systematic sampling. In this, the population can be divided into known groups and each group is sampled using a systematic approach. The number sampled in each group should be in proportion to its known size in the parent population. For example, the makeup of different social groups in the population of a town can be obtained, and then the number of questionnaires carried out in different parts of the town can be stratified in line with this information. A systematic approach can still be used by asking every fifth person. B. Stratified random sampling. In this, A wide range of data and fieldwork situations can lend themselves to this approach. Wherever there are two study areas being compared, for example, two villages or a population with subsets of known size, for example, one village with distinctly different habitats or hamlets. Random point, line or area techniques can be used as long as the number of measurements taken is in proportion to the size of the whole. For example, if a village was the study site, there would likely be different types of habitats, subsets within it. Random sampling may altogether miss one or more of these. Stratified sampling is possible when it makes sense to partition of the population into groups based on a factor that may influence the variable that is being measured. These groups are then called strata. An individual group is called a stratum. With stratified sampling, one should divide the population into groups, obtain a simple random sample from each group, collect data on each sampling unit that was randomly sampled from each group. Stratified sampling works best when a heterogeneous population is split into fairly homogeneous groups. Under these conditions, stratification generally produces more precise estimates of the population percentage than estimates that would be found from a simple random sample. Stratified sampling would take into account the proportional area of each habitat type within the village, and then each could be sampled accordingly. The sample points could be still identified randomly, A, or systematically, B, within each separate area of village. Advantages and disadvantages of stratified sampling. Advantages. It can be used with random or systematic sampling and with point, line or area techniques. If the proportions of the subsets are known, it can generate results which are more representative of the whole population. It is very flexible and applicable to many geographical enquiries. Correlations and comparisons can be made between subsets. Disadvantages. The proportions of the subsets must be known and accurate if it is to work properly. It can be hard to stratify questionnaire data collection. Accurate up-to-date population data may not be available, and it may be hard to identify people's age or social background effectively. Systematic sampling. Samples are chosen in a systematic or regular way. They are evenly, regularly distributed in a spatial context, for example, every 2 meters along a transect line. They can be at equal, regular intervals in a temporal context, for example, every half an hour or at set times of a day. They can be regularly numbered, for example, every 10th house or person. Methodology. A. Systematic point sampling. A grid can be used and the points can be at the intersections of the grid lines A, or in the middle of each grid square B. Sampling is done at the nearest feasible place. Along a transect line, sampling points for vegetation, pebble data collection could be identified systematically, for example, every 2 meters or every 10th pebble. B. Systematic line sampling. The grid on a map can be used to identify transect lines C and D. Alternatively, along a beach, it could be decided that a transect up the beach will be conducted every 20 meters along the length of the beach. C. Systematic area sampling. A pattern of grid squares to be sampled can be identified using the map of the study area. For example, every second third grid square down or across the area E, the southwest corner will then mark the corner of a quadrant. Patterns may be any shape or direction as long as they are regular. Advantages and disadvantages of systematic sampling. Advantages. It is more straightforward than random sampling. A grid doesn't necessarily have to be used. Sampling just has to be at uniform intervals. A good coverage of the study area can be more easily achieved than in random sampling. Disadvantages. It is more biased as not all members or points have an equal chance of being selected. It may therefore lead to over or under representation of a particular pattern. Cluster sampling. Cluster sampling is very different from stratified sampling. With cluster sampling, one should divide the population into groups. Obtain a simple random sample of so many clusters from all possible clusters. Obtain data on every sampling unit in each of the randomly selected clusters. It is important to note that unlike with the strata in stratified sampling, the clusters should be microcosms rather than subsections of the population. Each cluster should be heterogeneous. Additionally, the statistical analysis used with cluster sampling is not only different but also more complicated than that used with stratified sampling. Non-probability sampling is any sampling method where some elements of the population have no chance of selection. These are sometimes referred to as out of coverage or undercovered, or where the probability of selection can't be accurately determined. It involves the selection of elements based on assumptions regarding the population of interest, which forms the criteria for selection. Hence, because the selection of the elements is non-random, non-probability sampling does not allow the estimation of sampling errors. These conditions give rise to exclusion bias, placing limits on how much information a sample can provide about the population. Information about the relationship between sample and population is limited, making it difficult to extrapolate from the sample to the population. Example, we visit every household in a given street and interview the first person to answer the door. In any household with more than one occupant, this is a non-probability sample because some people are more likely to answer the door. Example, an unemployed person who spends most of their time at home is more likely to answer than an employed housemate who might be at work when the interviewer calls, and it's not practical to calculate these probabilities. Non-probability sampling methods include convenience sampling, quota sampling, judgment sampling, and snowball sampling. Convenience sampling. It is used in exploratory research where the researcher is interested in getting an inexpensive approximation of the truth. As the name implies, the sample is selected because they are convenient. This non-probability method is often used during preliminary research efforts to get a gross estimate of the results without incurring the cost or time required to select a random sample. Judgment sampling. It is a common non-probability method. The researcher selects the sample based on judgment. This is usually an extension of convenience sampling. For example, a researcher may decide to draw the entire sample from one representative city, even though the population includes all cities. When using this method, the researcher must be confident that the chosen sample is truly representative of the entire population. Quota sampling. Quota sampling is the non-probability equivalent of stratified sampling. Like stratified sampling, the researcher first identifies the stratums and their proportions as they are represented in the population. Then convenience or judgment sampling is used to select the required number of subjects from each stratum. This differs from stratified sampling where the stratums are filled by random sampling. Snowball sampling. It is a special non-probability method used when the desired sample characteristic is rare. It may be extremely difficult or cost prohibitive to locate respondents in these situations. Snowball sampling relies on referrals from initial subjects to generate additional subjects. While this technique can dramatically lower search costs, it comes at the expense of introducing bias because the technique itself reduces the likelihood that the sample will represent a good cross-section from the population. Bias in sampling is a systematic error in sampling procedure that leads to a distortion in the results of the study. Bias can also be introduced as a consequence of improper sampling procedures that result in the sample not being representative of the study population. For example, a study to determine the drug information needs of a rural population and plan of community drug use intervention failed to give a picture of the health needs of the total population because a nomadic tribe, which accounted for 1/3 of total population, was left out of the study. Sampling bias means that the data collected may not be accurate or represent the group. In statistics, sampling bias is a bias in which a sample is collected in such a way that some members of the intended population are less likely to be included than others. It results in a biased sample, a non-random sample of a population, or non-human factors in which all individuals or instances were not equally likely to have been selected. If this is not accounted for, results can be erroneously attributed to the phenomenon under the study rather than the method of sampling. Sources of bias. There are several possible sources of bias in sampling. The best known source of bias is non-response. Non-response is encountered mainly in studies where people are being interviewed or asked to fill in a questionnaire. They may refuse to be interviewed or forget to fill in the questionnaire. The problem lies in the fact that non-respondents in a sample may exhibit characteristics that differ systematically from the characteristics of the respondents. There are several ways to deal with this problem and reduce the possibility of bias. Seasonal bias. It may be that the problem under study exhibits different characteristics in different seasons of the year. For this reason, data on the prevalence and distribution of malnutrition in a community, for example, should be collected during all seasons rather than just at one time. Tarmac bias. Study areas are often selected because they are easily accessible. However, these areas are likely to be systematically different from more inaccessible areas. Selection from a specific real area. For example, a survey of high school students to measure teenage use of illegal drugs will be a biased sample because it does not include homeschool students or dropouts. A sample is also biased if certain members are underrepresented or overrepresented relative to others in the population. For example, a man on the street interview which selects people who walk by a certain location is going to have an overrepresentation of healthy individuals who are more likely to be out of the home than individuals with a chronic illness. This may be an extreme form of biased sampling because certain members of the population are totally excluded from the sample. That is, they have zero probability of being selected. Exclusion bias results from exclusion of particular groups from the sample. Example, exclusion of subjects who have recently migrated to the study area. This may occur when newcomers are not available in a register used to identify the source population. Excluding subjects who move out of the study area during follow-up is rather equivalent of dropout or non-response. A selection bias in that is rather affects the internal validity of the study. Bergson's bias or Bergson's fallacy is a result in conditional probability and statistics which is counterintuitive for some people and hence a veridical paradox. It is a complicating factor arising in statistical tests of proportions. Specifically, it arises when there is an ascertainment bias inherent in a study design. It is often described in the fields of medical statistics or biostatistics. The example is Bergson's retrospective study examining a risk factor for a disease in a statistical sample from a hospital inpatient population. If a control group is also ascertained from the inpatient population, a difference in hospital admission rates for the control sample and case sample can result in a spurious negative association between the disease and the risk factor. Survivorship bias, in which only surviving subjects are selected, ignoring those that fell out of view. For example, Using the record of current companies as an indicator of business climate or economy ignores the businesses that failed and no longer exist. Random sampling is the purest form of probability sampling. Each member of the population has an equal and known chance of being selected. When there are very large population, it is often difficult or impossible to identify every member of the population. So the pool of available subjects becomes biased. Systematic sampling. Systematic sampling is often used instead of random sampling. It is also called an nth name selection technique. After the required sample size has been calculated, every nth record is selected from a list of population members. As long as the list does not contain any hidden order, this sampling method is as good as the random sampling method. Stratified sampling is commonly used as probability method that is superior to random sampling because it reduces sampling error. A stratum is a subset of population that share at least one common characteristic. Examples of stratums might be males and females or managers and non-managers. The researcher first identifies the relevant stratums and their actual representation in the population. Random sampling is then used to select a sufficient number of subjects from each stratum. Sufficient refers to a sample size large enough for us to be reasonably confident that the stratum represents the population. Stratified sampling is often used when one or more of the stratums in the population have a low incidence relative to the other stratums. So students, we are done with sampling and types of samplings. Do you have any questions?
Ma'am, I have a question. Why should we be so careful about sampling bias?
Good question. Bias in sampling is a systematic error in sampling procedures that leads to a distortion in the results of the study. Bias can also be introduced as a consequence of improper sampling procedures that result in the sample not being representative of the study population. Any more questions? So, we are done with sampling and types of sampling. Thank you.